Hello class. This video we're going to take a look a little bit about exception handling in JavaScript so we can handle things that we don't expect to happen in the code gracefully and not have the application crash or the website, the web page not render properly. So we're going to start out with getting to our test environment and the JavaScript sandbox. We'll load that up and let's see what we have in there. And we have our basic lab template, which I will clear out because we don't really need that right now. So what is exception handling? Well, an exception is any error that we have in our programs or web pages that we don't expect. And from the JavaScript point of view, when an exception happens, it will generate an error, it will give a stack trace, and the script will stop running, which is not ideal because we want to make sure that we can handle that and continue processing our error or program regardless of the error, even if it's just to print a message to the user saying an error happened or some other event happened and some other action needs to be taken. So we could start out with a simple statement, and we'll just create a little variable called let result equals 10 divided by 2. So that is, excuse me, a simple statement. It just declares a variable, assigns it a value, and if we run it, it will run, and it will generate no output because we didn't output any console messages. So we can then put out a log message, console.log results. And if we run it out on our console, we will see the output of 5. So the statements we're going to use to try to catch an error, well, ironically, are try and catch. And what we'll do is we'll use the keyword try above the code where we think an error may happen. Now we have to have a little foresight here. So we have to think about places in our application where an error might happen and where we might want to be able to detect that and capture it and deal with it. So this is a pretty safe statement here. Let result equal 10. We can wrap that in a try. And we'll indent for readability. And we'll have our output. And we'll close out the try. So what this says is try to do these statements. If an error happens, well, we need to catch them, and that's where catch comes in. And in the catch, we want to do something. And we can do any JavaScript code we want. In our case, we're just going to print an error. And we'll print an error occurred. Yeah, not a great message, but good enough for now, just for demonstration. So if we run this piece of code, it's going to try to do these two statements. If it works, we'll see the output of 5 in our console. If it doesn't work, we'll see this message, an error occurred. So let's try it and see. And we see it generated the 5 again. So these statements passed successfully, and there were no errors, and everything was great. The catch code never runs because there was no error. So let us simulate an error. And the best way we can do that, or one of the easiest ways to do that, is to call a function. So I did not define any function, so I'll just call something undefined function just so it can generate an error. So what will happen is, when we run it, we see an error has occurred. So we did the calculation. We know that happened. The undefined function tried to execute, but there wasn't one. So the catch statement caught that error and instead gave us the ability to do some additional code, which was to generate, in this case, an error message. So you could see how we can now have a little more control over the program. So if something goes wrong, we can deal with it. So now that we've caught our error and it ran and we have our error message, we can continue processing and we can look at the output. Or can we? So if I want to print out results and I want to see my answer now, and I run this, I get an error, a stack trace. So why am I getting a stack trace error here? It's telling me that result is not defined. And that goes back to the var and let definitions of where a var variable or a let variable exists. So we need to take that into effect also when we declare our variables. We'll take a look at that more in a minute. But what I want to show next is the last piece of the try-catch block, and that's the finally piece. So finally says whether an error happened or not, I want to execute this code. So we'll just put another console.log statement in here. This always happens on Monday. So we're going to run our code again. We'll have our exception. I'm going to comment out line 12 for a minute. And we're going to run this code and we're going to see we're going to have our error and then we're going to have our second print statement when we run it. If I take out this undefined function, we'll see our result and then we'll see our this always happens on a Monday statement. So you can see you have a way to catch an error and do something. You have a way to do something regardless if there was an error or not, and then you continue your code. So this brings up another issue to talk about briefly, is the let and var. So you see with the let, we're declaring a variable let, and let gives the variable scope of the block, meaning wherever it is defined in the braces. So it is only available in the brace declaration, which is why when I run this, I get that error. See, here's what happens on a Monday. We get our output, we get an error, and then we try to print it. We can't because it doesn't exist in that scope. The scope is only of that block. So even if I take my result here, and let's say, well, why don't we just put it in the finally piece? And we can print it there instead, because that's part of the try-catch. And we can run that. And, oh, let me just get rid of this, because we have two of them. We don't need two of them. Oh, we get the same error. Well, again, result is not defined in this pair of curly braces, this block. It is only declared in this block. So how can we fix that? Well, we could take the let out and put it above, and that works. So it is now valid through the entire program. So we don't have to worry about what block it's declared in. So now we're giving it more of a global scope rather than a local scope to the braces. But I want to only have it in here. So how can we fix this? Well, we also have the var. The var definition of variables is another way to declare a variable, and this gives it more of a global scope. So this would give you variable access throughout the program after it's been declared. So if I run this now, we have the output we want. So you can think of L as a let as a local variable. You could think of it starting with L for local, and V as a global variable. It's too bad it doesn't start with a G for global, but it's just not L for local, so just go with that. So you can pick your variable type accordingly. Just note that the let is only available inside of the most recent braces, where var is available throughout the entire program. Okay, so let's expand on this a little bit with some custom error checking. So I'll demonstrate by Well, let me save this piece of code first for us, and we can use that later, perhaps in the sample code, so you have a reference. But let's create a new function, and let's make a simple function called divide, where we're going to take two numbers, x and y, and we're going to divide x by y. Yes, we can certainly do that as a math statement, but this is just to demonstrate an example. Clearly, if we want to divide, we do not want y to be 0, because you can't divide by 0. You get in most programming languages you get an error. Otherwise, in JavaScript you'll get it'll set the value to, I think, infinity, which isn't very useful. So it's best to check for 0, and we want to do something. I'll leave this something out for a minute. But if it's not 0, we want to return the value of x divided by y. Very simple function, divide x by y, unless we have 0. So we have 0, what do we want to do? Well, we can display an error message, which is okay, but we probably would want to instead be able to have a try-catch block, maybe somewhere down below, somewhere down in our program, and this could be, many lines later. Could be anywhere in the code, but we'll just put it here. We could put a try block in, and we'll do a console.log, and we want to do, let's say, divide 10, 0, or anything, 0 for that matter. And this will generate an error if we try to do this. So we want to be able to catch the error. And in our case, we want to print a message. We'll just print a message. And we'll put in console.log division by 0 is not allowed. So first we'll test the good case. We'll do a 10 divided by 5, and we will, we need more code up here. We didn't finish our statement. So if we do detect this, we want to be able to what they call throw an exception. So we can try the code, we can catch it when it happens, but in order to catch it, you have to throw it. So we're going to throw an error. So we're going to throw a message. And there is our throw. I'm going to change this up just a little bit, just so we don't have the same message in here twice, and we'll work on this as we go. And we'll clean this up later. So if I run this right now, I expect this to operate properly. The divide should give me the result of 2 when I log it. And we do, so that works. So we know that works, that's great. So now let's change our 5 to a 0, and we will run our code, and it printed infinity. Not exactly what we wanted. So the reason why is because we're throwing the message, but we're still doing the computation. So let's fix that up a little bit. Okay, so just looking at this, I realized that I don't want to check for x. I want to check for y, the denominator, not the numerator. Silly mistake. So let's try it again. And bingo, we have it. We have in the catch. We didn't see the message, so let's fix that. Well, in order to catch an error, we need to give it a variable. And we can call it ARR or error or exception. We'll just stick with error for now. And we can print out the message that we received. So we've created our variable. We just need to print it out now. And we can run our code. And now we have our custom message. So to throw, the string that we've created will come down and be caught and stored in this variable, error. And then we just simply print the error. So now we have the ability to throw custom messages and have them be caught in our main program. And we can, well, do other things with it, but we don't have to just display a message. We can do some other logic if we wanted to. JavaScript also gives us the ability to, instead of throwing just string messages, we can throw a complete object. And the object allows us to have more granularity, more detail in the error if we wanted to do something particular. So instead of throwing just this message, we're going to modify it slightly. We're going to give it new, so we're indicating an object, and we're going to give it the error object. And we'll wrap it up properly. So now we're throwing an object. So what this is saying is create an error object, give this its message. And now when we go to capture the error, we can still use error as the name of it, and maybe we should change it so it's not misleading with the capital E and lower key. We'll call it exception. We have the ability to use exception piece properties. So we can print out exception.message to get the message that is included in the error. And there it is. So to wrap it up, there are a few other things we can do with the exception object. Most are out of scope of this class and probably more for full-on JavaScript development. You can do other things such as you can get the name of the error if you wanted to see what the name of it was. And we know it's error because that's what we called it. And the error object can be broken down into many sub-objects or subclasses. Again, we're really not going to get into that. We don't need to do that here. You can get the stack trace. Maybe you want to have the stack trace. So remember, this stack trace now that we're seeing here is not from the failure. Well, it is from the failure, but the program is still running. We're just displaying the stack trace. So I can prove that by putting another statement here. That's all. And we can run it. There, to demonstrate that the stack trace was from the program itself, not from the program crashing. So you can use this, maybe you want to log it to a database to have it to review later to find out what happened, or something like that. So you can now do a little more than just have your program crash and figure it out. You can actually handle it and make it work regardless and have the user have a better user experience. Okay, so that's it for now. Try it out, give it some practice, and we'll see you in the next one.